All right, good afternoon, everybody. So today we're going to be looking at finishing up our ball on floor lab that we had started setting up last time. So again, we'll just kind of take a look at all the things involved with that and walk you through how to finish this up. So first off, in the lab, the way that it's going to work is a ball is going to be rolled down a ramp, and the ball is going to roll past different markers, and we're going to be able to see that in the video. And each marker is set up. The first one is set up at 0. The second one is set up at 0.5 meter, then 1 meter, 1.5 meters, and 2 meters. And we'll be able to roll the ball down and see what time it says on the Chromebook at each of those markers, and then fill in the data table with that. So that's what we're going to be looking at today. For these slides, you are going to need to have access to them. So just a quick reminder of where to find those. If you go to your class period, I'm on 8th, but 6th is the same. And you go to classwork, class materials, and the Unit 1 patterns. This is going to have all the slides for Unit 1. And so this is where you go each day. If you miss a day, you can always go back and see what was done that day. Since today is the 17th, we're looking at this, September 17th. If the link doesn't work for whatever reason, it is slide 71, so you could just scroll all the way down there. But for most people, this link should work just fine. And you click it and it drops you right where we need to be. All right, so we're going to go ahead and take a look at the videos that were collected since we won't be able to do the lab in person today. We've got a link that says click here, and so that's what we're going to be looking at, this link right here. And if we click there, we'll be able to open up these videos. And if you save these videos onto your Chromebook and move them into your Google Drive, or just save them directly into your Google Drive, it's going to make it a lot easier to play them. The controls are better if you play it through the Google Drive. So that is my recommendation. First thing we're going to do, again, let's get my feet out of the way here. So we can see all of these markers, right? Each of these is at the 0, the 0.5, the 1, the 1.5, and the 2 meter mark. So we just want to know when the ball gets to each of those spots. And this is, of course, the time that we're looking at. Now, I just left my timer running, so you don't really need to worry about it. We're just going to see what time it is at those marks. Just for ease and convenience, do not put in the minutes, right? It's 2 minutes. It's going to be 2 minutes this whole time. Don't worry about the minutes. Just worry about the seconds and the 1/10 of a second. And I'll show you the first one together so we can kind of look through it. Another tip is that you can always go back to playback speed and drop that to 0.25. And that can make it easier to see when the ball is at a certain spot. So we can play. And again, we can just watch the ball rolling and pause it when it gets to that first spot. If we miss it, right, we can always just go back and redo it or pause it again. So there's the ball rolling. And again, we're trying to stop it when it gets to that bottom mark. Maybe I went a little too far. I could always back up a little bit here. Okay, that looks pretty good. Again, we can see 2 minutes. We're going to ignore that. 52.6 seconds. So that's what we're going to put into our data table. So let's go ahead and look at that. This is the lab itself. Again, you guys should have answered all these top parts. Should have done the hypothesis. We're looking at this data table part. So right here it says click on this. It says copy. So if we click on this, it'll open up, but we're going to have to make our own copy of it. Now, I already have a copy of it open, so I'll just go ahead and open up that copy. And again, 52.6 that was our time for that first location. The distance was 0. That was the first spot. So again, I would let it keep going and pause it again when it gets to the half-meter mark. So I'll take a look at that. Oh, again, I went a little bit too far. I'm going to back it up a little bit. Oh, too far back. Inch it forward. That looks pretty good. It looks like it's switching between 52.9 and 53. If I'm not sure, I can always play it a little bit and see what happens. Yep. So if I go to 53, it's a little bit past that. So I'm going to go back to the 52.9 mark. So again, in my data table, here's my next one, 52.9. And then I'm going to keep collecting. Now, we stop at 2 meters, right? So you're not going to have anything in these spots here, right? You're not going to have anything in those spots. So we're just going to ignore those spots, right? We don't really have enough room in the classroom to go a full 3 meters, especially if a bunch of people are doing stuff. So we're just going to deal with these. So again, we'll go ahead and let it play. We'll stop it at the 1 meter, record that. Stop it at the 1.5, record it. Stop it at the 2 meter, record that. And this is our first video done, right? Now we've got these other videos. And again, all of these are linked, right? When we click this link, it'll bring us to this folder that has all those videos. So your first video is going to go here, then your second video, and then your third video. So all those times will just get put in, and all of the stuff is going to be pre-calculated for you. So you guys don't actually need to do any calculations. Notice that it's already doing some stuff here. It's saying, let's say that we had started the timer when it was at the 0. Well, then it would have only taken 0.3 to get from the 0 to the 0.5 meters. And we can see that that's just subtracting these values for us. So it's already calculating stuff. That's why we could just let the timer run and not have to worry about anything. Now, before I move on, I just wanted to remind you guys, yes, you are filling in these 3 trials. And yes, this is what you're going to be graphing, right? It says graph on x-axis, graph on y-axis. So this is what's going to go into Desmos. But before you do that, we want to make sure that we don't forget about the controls and qualitative data here at the top. So up here, controls, remember that controls are the things that stay the same from experiment to experiment. So what are the things that we want to make sure stay the same? So again, sometimes watching those videos is going to help you think about what is staying the same, right? The way the ball is dropped, the ramp height, the ramp material, the floor material, the ball, all those different things, right? So you need to list off a couple of things that are staying the same, controls. Qualitative data are just other observations that you might make during the experiment. So is anything happening during the experiment that is worth making note of? Again, not always, right? But you should at least find something, right? It might not be in every video, but at least something. Like when the ball rolls down, it's bouncing. Oh, and then it hit a ruler. Does that affect things? Maybe. We need to make note of that, right? So you want to make observations of like what was going on so that if something does have an effect on your times or your data, we can look back and see, oh yeah, maybe it was this thing that happened. When you have finished with putting in all of your trial 1, trial 2, and trial 3, make sure that you take a screenshot of this, right? And we want to make sure that controls, qualitative data, and all of your data are all in that screenshot. If you need to, you can change the zoom up here. So maybe drop it down to like 75, and that maybe is an easier way to get a screenshot of what you need. But either way, make sure that you have all of those things. Some people do 2 separate screenshots. One for their controls and qualitative, and then one for their actual data. And that's fine too. Again, kind of whatever works for you guys as long as you have all of that information. And we're going to just paste it right back here, right? It says copy and paste it back here. So we're going to just paste that screenshot right here. So I'll just do kind of a quick little screenshot. And then that's what I want. Again, I don't care about 2.5 meters. I don't care about 3 meters because we're not doing those. And then you just paste it back there. Oh, that's really big. I don't want it so big. That's fine. You can change the size of it, right? If you like that size a little bit more, just change it a bit. Okay. The next thing that we're looking at is the Desmos link. So again, this will take us right to Desmos. Again, I already had it open, but that's okay. So T and D, we've got this little area here that says enter your data below. And if we look at our data table, well, this is what says graph on X and graph on Y. This is time and this is distance. I bet we can figure out which one is the T and which one is the D. So then you would just fill out all of these things. First one, again, I don't have complete data here, but first one for me was 0 and 0 and 0.3 and 0.5. And so I've got a couple of points. Obviously, you will have a lot more points. Once you've done that, again, the really nice thing is that all of these steps for Desmos are up on the board. And so you can also follow along with the slides, right? It says, don't forget to set up your controls and qualitative data, collect your data, graph it on Desmos. Steps are on the wall, right? So that's easy enough. So if we look back here, right, the second step is click and drag the C slider. So that's the C slider here. And we want to see when does one of these fit our data. Well, the purple line, at least with the data I have so far, doesn't look like it's a good fit. Maybe it would be in between those two, who knows? The green one, not so much. The blue one and the red one, maybe, right? Maybe the red here, maybe the blue here. Again, we'll need more data to figure out what looks good. And you should have enough data so that one of those lines fits what you want. Whichever one it ends up being, again, you can just hide the ones that you don't want. Now, we said it definitely wasn't purple, but I'm just going to use purple as an example. So if it was purple, right, I'm keeping the purple line. And my math model is based on this y equals c. Well, I know what the y-axis says. It says distance. Great. But instead, if I've got this line, which we also said it definitely wasn't, then I would have, instead of d, I would have distance equals the c value, which is 0.3, divided by t. Again, we can check the time axis to figure out that t is time. If we like the blue line, right, let's get a value that looks a little bit better. So then it would be something like distance equals 5 times squared. Distance equals 5 times squared. If we picked the red line, again, I'm just adjusting the C slider to fit the data a bit. It'd be something like distance equals 1.7 time. And you could put like a little times time if you wanted to. Little X or little asterisk or something like that. You can. Some people put times in parentheses. Again, whatever makes the most sense to you is fine. Again, as long as you write that mathematical model in. So we would just scroll down a little bit and then write that in here. Distance equals, I don't remember what it was, maybe it's 1.7 time. Great. Again, you could do like something like that if you want to, or something like that if you want to, or throw in some parentheses. Again, whatever looks good to you is fine, as long as it is something along these lines. Don't forget, when you're done with this, obviously this is not done, you would want to take a screenshot of it. Make sure that you have your axes in there. Make sure that you have your points, your line, which I don't have a line in there, and your math model so that you can then paste that right underneath this graph section. Again, if it's super big and you don't like it that big, shrink it down. Right? That's totally fine. All right. Conclusion. Let me go back up and delete these before I forget about them. Okay. Conclusion. So again, if we're looking in the slides, we can kind of see what was going on. This is an example of a good graph, right? It's got the labels on the axes, it's got the points, it's got the line that goes through those points. If these points happen to be yours, you would have an equation that looks something like this. So your math model would be distance equals 2.4 times time. If this is what you found, then of course the pattern that you'd be looking at would be a proportional pattern. Proportional again is up on the wall so that you guys could see that. The basic idea here is that the equation is y equals cx. The math model for us would be distance equals 5 or whatever your value is times time. And the relationship is that when x doubles, y doubles. So when you, again, if we're looking at this equation here, when you let the ball roll for twice as long, then it goes twice as far, right? That's that relationship. All right. Last thing is our conclusion sort. And what we want to do is we want to rank these sentences. So we've got a link that we can take us to all of these sentences, and we want to rank them as the low quality, medium, and high quality. And then we can kind of get all of the high quality ones together and put those into our conclusion. So again, we'll kind of follow that link off of the slides there, link at the top, and it takes us to this. It says, what makes a good conclusion activity? Rank these sentences as high, medium, and low, and then copy the high ones to our lab. So first up, they're color coordinated to try and help you guys identify what goes where. These are all red. These are all our claim. So first claim here, after investigating the behavior of a ball on the floor, I conclude that there is a proportional relationship between the ball, or between the time the ball rolls and the distance the ball rolls. Okay. Second one, after investigating the ball on the floor, I conclude that there is a proportional relationship between the independent and dependent variables we measured in this lab. Third option, I conclude that there is a proportional relationship. Okay, so now we have to decide which of these do we think is the high quality, which one do we think is the low quality, and which one is the medium quality. And again, we're going to be copying the high quality ones into our lab right here. So it does say picture, you can do screenshots, or you can just like copy and paste the text. Whatever makes the most sense to you is fine. I'm going to copy and paste the text because I like that. Look at that a little bit more. So you probably realize that this is the low quality. And then really you're kind of debating between these. And in all honesty, I would understand why you would pick either one. A truly good, high quality would actually be a bit of a combination of these. Because what we really want is we want to know what was done in the lab. So this is actually going to be our high quality. So I'm going to copy this and paste this into my lab write-up. Boom. But some of you guys might be thinking, yeah, but there was that other part that I really liked about the other one that specifically talks about the relationship between the independent variable and the dependent variable. And I agree with you. And I would put that in here. So I would say that this would actually be our best bet, is if we had something like this where it was, I conclude that there is a proportional relationship between the independent variable, the time, actually the time the ball rolls, let's go ahead and put parentheses around all of that, and the dependent variable. And then again, we can put parentheses around that one. Because in truth, the best of the best, when you guys start writing your own conclusion, you're going to want to talk about the independent and dependent variable. But just as importantly, we want to know what those actually are. And that's why this second one here is not great, right? That's why it's just a medium, is because it talks about the proportional relationship. Great. It talks about the independent and dependent, but we don't know what those are. So that's not super helpful. We want to know what those are. So that's why I would say that in truth, when you guys start writing your own, a really good quality is going to kind of combine the best of both of those two. All right. But if you just copied the first one, right, and use that first one, that's fine. And then we'll move on to sort of the yellowish orangey color here. And again, this is our evidence for the claim. And we need to decide which of these is high, medium, and low quality, and then copy the high quality and paste it into our write-up. We'll do the same thing for the green. And again, you can change your C value here to whatever your actual number is. 1.7, 1.3, 2, whatever your value actually is. If you want to change it for the high quality, that would be great, just so that it fits with all of your stuff better. But copying and pasting is fine too. So that is our next section, and then we get into the blue section here, which is our prediction part. Again, if you want to make your prediction, I'll show you guys how to do that here in just a second, and we can basically recalculate how far we think it's going to go. And actually, yeah, I'll pause here and we'll go take a look at that. So if we have our Desmos, let me get my proportional line back on there. If this is our line, right, it goes through two of those points. Who knows what yours will actually look like, but it should look similar-ish. And we want to see what happens when the time is 6, right? How far will the ball have rolled? We can actually click and sort of drag along this line here, and we can see that it goes about 10.2 meters. That's how far the ball would roll if we let it roll for 6 seconds. So we didn't have to do any math there. We could have, right? We could have plugged in 6 for the time. 1.7 times 6 is apparently 10.2. Great. But Desmos can solve that for us, again, just by kind of scrolling up and down here. So that would tell us what our prediction was. So when we're making our prediction, we could change that value there to the 10.2 that we would get from Desmos. Again, allowing it to fit our actual data. Last bit here is the confidence. And again, we'll continue talking about this because the confidence stuff is a little bit weird at first. But we're going to kind of take a look at these and see what our confidence should be based on our data. And again, it's actually going to differ depending on what data you were collecting. Let me delete this again before I forget to do that. Actually, let me put back that. Good. Okay. So parts of the conclusion, again, it kind of, at the end of this lab write-up, it shows us all these different things so we can kind of double check. And this will be on other labs so that you guys, while you're having to actually write your own full conclusion, when we get to that point, you guys will have these to kind of make sure, did I do all the parts that I need? So scrolling past that part, we get into this thing here, which is called the confidence matrix. Determining confidence in a prediction. So we have these two sort of axes that we have to deal with. The first is looking at where our prediction is. If we're predicting something inside of the data set, so for instance, right, we've got these 2 points here. Let me just kind of zoom back in on them. If I'm trying to predict something over here, then our prediction is going to be a lot better. And that's because we knew where the ball was at 0. We knew where the ball was at this half a meter mark. So knowing where it is in between, we should be really, really precise and know that for sure. We should be really confident about that. If you're predicting something just a little bit outside of those two things, we can still be reasonably confident. But if we start trying to make predictions that are like way outside of our data set, and the way that we kind of make a rule for that is if it's more than double. If it's more than double our highest value, then we're not as confident. We're not sure that those patterns hold true. So what these diagrams are kind of showing is that if it's inside of our data set, then we're looking at this column here. Our confidence is more sort of on the higher end of things. If we're looking at something that's just a little bit outside of our data set, right? It drops our confidence a little bit, but not a ton. We're still decently confident. And if we're predicting something way outside of our data, then our confidence drops even further and gets a little bit lower. The next thing that we're looking at is this side here to find out which row we are in the column. So we figured out what column we're in, and now we're trying to figure out what row we're in. And for this first one, this is where all the points, right, line up perfectly, right, or near perfectly. It's never going to be perfect, but it should be darn close, right? And that tells us that we're in this top one. That means that our data is pretty good. So maybe we've got a line, doesn't quite line up with all the dots, but maybe there's more dots out here and then a couple strays here and there. It's great. That's fine. If it goes through all the boxes, you're pretty much in that first column, first row. This second one here is the best fit line is near the edges of many of the data points. So if it's near those boxes, right, but maybe doesn't go through all those boxes, I should just throw in another point here so we have like an idea here. If we're looking at 1, maybe we're looking at there. So that's getting near the edge, right? And maybe I can make this off a little bit further. So if that was way up there and my other data points were more on the line or below the line or something like that, and it didn't quite go through that box, we'd be looking at that second row. So that would drop us down to this one. For us, our data is probably pretty good. Again, we'll see what you guys get from the video, but videos definitely tend to make the data a little bit better. And we're predicting something that's a little bit outside of our data set, right? We only went to a couple meters here. So again, depending on what your data looks like, you might be looking at this medium-high range. You might be looking at this medium range for your confidence. Again, it's different for every group. It's different for every set of data. And so you need to kind of decide what fits with your data. So again, we'll talk more about confidence and confidence matrix stuff later on. But you'd be able to copy one of these and put that into your lab as well. So that should finish off your conclusion. Don't forget to do the research extension question. And again, I reminded a lot of people to do this as soon as we were starting to talk about the ball on the floor and all the really good questions that you guys were coming up with in terms of what we could be asking questions about. those are all research extension questions, right? Instead of letting it roll and seeing how long it takes to go certain distances, right? We could have tested any other thing, right? How does the ramp height affect it? How does the size of the ball affect it? How does the mass of the ball affect it? How does the material affect it? Any of those questions that you guys were coming up with can go into this research extension question. Again, don't forget to have your sort of two different parts. If we change this, how does that affect that, right? So you've got to have your two this and that parts. All right. When you finish with that, again, don't forget to go back and finish off anything that you have from that last lab, the pendulum lab. I know a lot of people were a little bit behind on it, and we do have some extra time during class. So make sure that you guys are using that time to get caught up on what you need to get caught up on. And again, if you're getting stuck on any of that, right, there's the slides that'll help you figure out where you need to be. Pendulum, if you're missing the beginning of it, go to pendulum day 1. If you're needing the pendulum day 2 stuff, right, go to that one. So all of these should link up with whatever area you need to get to. And there are the videos that I posted with those assignments. So if you need those. All right. Hopefully you guys don't have any questions, but if you do, make sure that you guys are checking with your table partners and seeing if they can help you out. Otherwise, best of luck, and I'll see you guys next time.